welcome back. In this final lecture on electric hybrid vehicles, we will see how a fuel cell can be integrated with a battery to run a hybrid vehicle and what are the advantages of such an integration. A fuel cell hybrid vehicle operates in this manner. A process sheet is shown here. So there is a chemical or rather an electrochemical energy conversion where, let's say, hydrogen fuel um, is oxidized with O2 or air in a fuel cell um, to generate electrical power. So hydrogen fuel is supplied to a fuel cell along with air, and then electrical power is generated. So this electrical power can go either towards charging a battery or running auxiliary load like air conditioning, a radio, and so on. Or it may go towards running a motor which provides power to the car to moving the wheels. So these are all two-way arrows. Not only the fuel cell can supply this power, a battery can also do that. So that's an important aspect. So there is no internal combustion engine, but the integration that makes it a hybrid is because besides a battery, you also have a fuel cell. One thing you have to remember is that the big advantage with all these electrochemical energy conversion devices are that they are not limited by the Carnot efficiency, whereas an internal combustion engine is limited by Carnot efficiency because in an internal combustion engine, thermal energy is converted to work. Here, both batteries and fuel cells are not limited by Carnot efficiency. We have addressed this issue in a previous lecture. Please refer to that lecture to understand this in a deeper manner. So this is the flow sheet or a schematic of a fuel cell hybrid vehicle architecture. So the next thing is that there are aspects of fuel cell efficiency that has to be taken into account to run the system efficiently. You may define the fuel cell efficiency in the following manner. VI is the power that can be obtained from a fuel cell, but when we have a fuel cell system, as was covered in previous lectures, you have certain auxiliary power requirement. This might be the power requirement for pumping the fuel into the fuel cell, or you may want to operate a blower that removes heat from a fuel cell. All these things consume some power. So not all of the power that is generated from a fuel cell is available for the vehicle. Some of it goes towards operating these ancillary devices. And in addition, you may have electrical losses, right? So there can be wire losses in the wire from the fuel cell to the vehicle and so on. These are all have to be taken into account to define the fuel cell system efficiency. This is the energy available from the fuel that is in the denominator. So that is what is plotted here. The efficiency of a fuel cell goes in the following manner. You may be able to appreciate why this is so, because when you operate at very high power, that involves very high currents, it increases the losses in the fuel cell. You may not, you should not be in the transport over potential region. All these things have been covered in previous lectures on fuel cell. So the efficiency falls down when you are operating at very high power. When you are operating at very low power, that is, the power from a fuel cell is much, let's say it's less. Compared to that power, the power requirement for the auxiliary devices can be quite a bit. So if this is comparable to this, that is also not advantageous. That's why there is a loss in efficiency in this region. So you do not want to be operating at very low power or very high power um, regimes. So you want to be operating pretty much close to uh, power wherein there's maximum efficiency for a fuel cell. So the other data that is being presented in this plot is that the vehicle does not operate at constant power, right? The vehicle speed might change. It might be accelerating, it may go at low speed, or suddenly will go at high speed, for example, in a freeway and so on. So what is presented here is the fraction of the time um, where the vehicle needs, let's say, 10 kilowatt, 5 kilowatt, and so on. So this fraction also varies time to time. So putting all these things together, you may design the fuel cell battery hybrid system in the following manner. The fuel cell might always operate at a constant power provided by these dashed line. That might be the operation of the fuel cell. When the total power required is more than what is supplied by the fuel cell, the battery power will kick in. So the battery gets depleted. When the total power required by the vehicle is less than the power that can be supplied by the fuel cell, the excess power goes towards charging the battery. So this is the way you may operate between the battery depleting mode and the battery charging mode. So this power might be chosen based on the power wherein the fuel cell is most efficient. So such kind of design consideration have to be thought through to design a efficient fuel cell battery hybrid electric vehicle. So overall, we have looked at a variety of issues in this lecture series on hybrid electric vehicle. First, we looked at why a hybrid is efficient. The crucial factor here is the internal combustion engine is most efficient in a very narrow regime of speed and torque requirement. So if you want to go beyond this region of operation, it's useful to supplement the power via a variety of hybrid designs. So we looked at variety of hybrid architecture and the trade-off associated with different series parallel start-stop hybrid architectures. The most crucial factor you have to appreciate is the so-called range anxiety of electrochemical energy systems. The battery cannot, the energy capacity of the battery is much less than the energy density and the power density that can be obtained from, let's say, gasoline or a petrol vehicle. So if you can extend the distance or the range that can be traveled via battery power, that's going to be a great game changer. And if you can eliminate precious metals from the battery, let's say if you can eliminate cobalt from the battery and so on, you can bring down the cost. So increasing the range and decreasing the range are the frontier research areas in this um, hybrid vehicle or all electric vehicle. So if this can be increased, this can be brought down, the acceptance of battery and hybrid vehicle is going to be much more. With that, we conclude this lecture series on electric and hybrid vehicles. Thank you.